The Solis inverters actually work to power the pump now with the grid off, sort of. So this is straight out of the comment section. Let me catch you guys up. If you're new, here's the 30 seconds. Skip if you want to skip it. Powering a 5-horse well pump. It is a massive pump. It's about 500 feet down, and then it pushes out 1,000 feet laterally in kind of two different directions to several properties. One Solis wasn't powerful enough to do it with an LG battery. Then one Solis with two LG batteries didn't do it. And then two Solis inverters with two batteries, one battery each, should have absolutely been able to do it. However, it would work fine until I turned off the grid, which is actually my 6000 XP off-grid inverters that are powering it through this box right here coming up. Now, when I would turn off the grid, these two would no longer power the well pump. It's a huge pump. It takes, I think the LRA on it is 125, and it is a 240 volt pump, and it pulls, when I do my inrush test, 85 amps of inrush. Now, with that out of the way, let me tell you where we're at today. This is absolutely going to be the last video in this series, but I felt like if I didn't do this video, then I wouldn't actually be being honest about where I'm at and how I'm ending it. I didn't even know I was going to do this until this morning. So what happened is I came out here because I've already purchased the equipment to replace this, and we'll go into that here in a minute. So I've got the equipment. I went up to Signature Solar to pick it up. They're actually donating parts of it. So what's going on is I came in, a couple of you guys noticed in my last video, and we'll do it right here, when I turn off the power, the grid, light flickers. The master inverter, which is on the right, which I feel like it should be on the other way, but this was the first one I installed. It has an orange status showcasing that there is something that's messed up. However, what I did not notice that a couple of you guys pointed out, or I guess I noticed it, but I didn't really think through the implications, is that this one is actually red. So that is a hard fault. Now, I assumed, because the light is still on up here, okay, that these guys were still powering through the inverters. However, if I come over here with my multimeter and I check this one with these two off, this is the master inverter and this is the slave. The master is actually getting power, 240 volts, and the slave is not putting out anything. So this guy actually is in a fault. Okay, so what do we do with that? I jumped on the app, I'm looking at it, and I'm not seeing any sort of indication that there's a fault. It's not telling me anything. So I came in and I connected directly to this inverter through the Bluetooth on the app, and it still didn't show me any faults or any errors. But just as I'm checking this, I hear a click, which we should hear in a minute or two. And what happens is it clicks, this turns from red to amber or orange, and then it's powering and it's synced up with it. Now, this is not the way it should be working. This is not ideal. However, once that's done and we're fully off grid and I flip this switch, it's gonna run. And it does exactly what I need it to do. It does everything that I wanted it to do, except it goes down if I try to turn the well pump on right now while this one is still red, because this guy still does not have what it takes by itself. These are 11.4 kilowatt output inverters with a peak of, I believe, 22,000 watts. That pump should be able to handle that. In fact, if you check out this video right here, wherever it is, you'll see where I ran a single 12,000 XP with this one single big battery, Husky 2 48 volt battery, and it ran just fine. I've run it on a 6,000 XP from EG4 as well. One of these on paper should do it. However, they max out at 70 amps of max discharge all at once at surge. And this takes, you hear that? You probably didn't hear it. I barely heard it. Look at that. Now we are amber. So with that, and I think I'm using my earpiece here as my mic. So it might not do it. Okay. I was turning that off to make sure we still had power. I'm gonna flip it on. It's gonna power it, but you might not be able to hear it. You just have to trust me. In fact, let's go ahead and get our inrush. So I'm gonna go amps, and then I'm going to do inrush, and I'm gonna hit my range over 1 so we get 3 decimal points. Try not to shock myself, and I'll show you this when we're done with it. You see the lights flicker, the well pump kicked on, and if you've watched this series in the past, you will know that it goes, and then the lights go dim, and it's just a disaster. So I'm going to turn that back off, and I'm going to show you my 85.2 amps of inrush, which is over the capacity of one of these, which is why when this one is in fault, this one cannot do it by itself. But once it wakes up and decides that it's back on track, then it will actually power it. And this is exactly what I needed. So I could leave this system in place, but I'm going to repurpose it somewhere else. I don't know what I'm going to do with it yet. It will be repurposed, and it's going to come down, and I'm going to install a FlexBoss 18. So if you're interested in seeing that, it'll be over here whenever, at the end of the video, whenever that's done. I'm also going to pair it with a big battery, and then the Husky 2 to show how a single Husky 2 can run this. It's pretty cool. I've got a couple other batteries lined up from other manufacturers that we're going to try out as well. So stay tuned for all of that, and let me know what you think. This series has been interesting, and I wish that this had the instant transfer, like the UPS instant, like 20 millisecond backup, but unfortunately it's more like a 3.5 minute backup. That's pretty much it. Check out this video whenever it's out, or this one. It's the next best thing. Thanks for watching. See you on the next one.